Okay, so now we're going to intro linear equations. Linear equations is what we're going to be dealing with for the rest of the semester. Okay. So linear equations, first thing you should probably notice is that linear, line. Okay. These are going to be lines. We're going to be dealing with lines. Okay. Now a couple things about linear equations. First up is that there's going to be two variables. So when we're solving equations, all of our equations only had one variable. Okay, we were solving for x, or we were solving for, z or y. Linear equations are going to have two variables. There's going to be an x and there's going to be a y. Another thing to notice, or at least take note of, is that all linear functions are, or all linear equations are functions. All linear equations are functions, which means they're all going to pass the vertical line test. Okay. Again, in Algebra 1, all we deal with is functions, so it has to be a function. Okay, now each time we introduce a new function, we're going to go through the same steps. We're going to talk about the parent function. What the parent function is, and all types of functions have a parent function. It's the simplest form of the equation. Okay, the simplest form of a linear equation. Okay, so it's the most basic version of a linear equation. The parent function, or the equation for the parent function for a linear equation, is y equals x. Okay, so all linear equations are going to be built off this parent function, just like, all children come from their parents. All, every type of linear equation is going to be based around this y equals x function, this y equals x equation. Okay. All right, well, what does y equal x mean? Well, remember how we can write functions. We could write functions as a table, an xy table. Remember that x is the input, y is the output. So if x is the input and y is the output, and y equals x, that means anything you plug in for x, the same thing is going to come out for y. So if you plug in -2 for x, well, y is also going to be -2. And if you plug in -1 for x, y is also going to be -1. Okay? Y equals x. So they're always going to match. So 0, 0, 1, 1, 2, 2. From that, we could create a graph. Okay, so remember the other way we could write functions is graphing them. So if we graph these points, remember when you're graphing points, the x-axis is the horizontal one, positive axis to the right, negative axis to the left. The y-axis is the vertical one, positive y goes up, negative y's go down. So when you're graphing ordered pairs, you go over the x value, left or right, left if it's negative, right if it's positive, and you go up the y value, positive up, negative down. So -2 to -2, you left 2, down 2. Left 1, down 1 for -1, 1. Because again, each of these x, y's, those are ordered pairs. Okay, 0, 0 is the origin, 1, 1, 2, 2. Okay. And we connect those dots. Okay, so I call this the main diagonal. It goes through the origin, it goes, and each of the ordered pairs match. So we just graph the line through the main diagonal. And that's the graph of your linear parent function, y equals x. Okay. So all of our linear functions are going to look like that. Now again, when we go through the parent functions, we're always going to kind of describe the graph in these four manners. So we're going to state what the parent function is. We are going to state what the shape of the graph is. We're going to state the domain and the range. And we're going to do this for the other two functions that we introduce throughout the year. Alright, the parent function in function notation, because remember function notation is a little different than y equals form. Function notation will be f of x equals x. Remember y and f of x are interchangeable. Okay. So y equals x, f of x equals x. It's the same equation, just in function notation. The shape. Okay, we already mentioned the shape. Linear functions, linear equations form a line. Or a straight line, but all lines are straight. Domain and range. So remember, domain is how far left does the graph go and how far right does the graph go. And range is how far down does the graph go and how far up does the graph go. Okay, all the possible x values for domain, all the possible y values for range. Okay, well, if you look at our graph, we have arrows on both ends. So this down arrow means it's going to go down forever and left forever. This up arrow means it's going up forever and left and right forever. So that means both of these, domain and range, is going to be all real numbers. Okay. So you could write it with the all real numbers are. You could also write it in interval notation, which would be negative infinity to positive infinity. So either one. That just means the entire graph is being used. All the x values, all the y values. Okay. Alright, so all of our linear equations are going to be based around this form. They're all going to have domains of all real numbers. They're all going to have ranges of all real numbers. And they're all going to be shaped like a line. One thing to note about linear equations, so look at the equation we had, y equals x. Okay. One thing we want to note about this is that's x to the first power. Okay. The exponent, we don't write exponents of to the first power because everything's being raised to the first power. But one thing to note for this is that the exponent of a linear equation is always 1. So the exponent on a linear function or linear equation is always going to be 1. It's always going to be x to the first power. Okay, which brings us to the next section. So that's what a linear function is. What's a linear function not? Okay. So is any equation a linear equation? The answer is no. So we got to determine what's not a linear equation. Okay, there are 3 things that can make an equation not linear. If you have variables that are multiplied together. Variables multiplied together, that's not linear. So anytime you see like an x times a y, okay, not linear. The second thing, exponents on the variable other than 1. Okay, so we said that the exponent on the x value of a linear equation is always 1. If there's ever an exponent that's not 1, it's not linear. So if you ever see an x squared or an x to the third or a y squared, that's not linear. Okay, or any other exponent on a variable. And the third thing is if you have a variable in the denominator. Now this isn't to be confused with a fractional coefficient. Okay, you could have a fraction in front of a variable, but you can't have a variable in the denominator. So if you ever see something like 1 over x, okay, that would not be linear. But if you have something like 1/2 times x, that is linear. Okay, it just depends if that variable is actually in the denominator or if it's next to the fraction. Next up are solutions to linear equations. How do you find a solution to a linear equation? Okay, well, since there's 2 variables, the solution to an equation was always whatever x equals. Now we have 2 variables. So a solution to a linear equation is going to be any xy pair, any xy ordered pair that makes the equation true. It's also any point on the line. Okay, so you graph the line, any point on that line is a solution to the equation. So any point on the line, any point you find an ordered pair from the line, that's going to be a solution to the equation. Okay, so I've set up some example problems asking if a certain ordered pair is a solution to a certain equation. All you have to do, so this first one is 2, 6, a solution to the equation y equals 3x plus 1. All you're going to have to do is plug in the values. Remember, we have an xy ordered pair. Okay. So if we plug in 2 for x, and we plug in 6 for y, and we get a true statement, it's going to be a solution. Okay, so let's do that. We'll plug in 6 for y. So instead of y equals, it's 6 equals. Instead of 3 times x, we'll have 3 times 2, and then plus 1. Okay. And then just evaluate. We're not solving anything. There's no variables that we're solving for. You're just going to evaluate. On this problem, the left side is already evaluated. It's 6. Okay. So now we just have to see if 6 equals the right side. The right side, 3 times 2 is 6, but you still have that plus 1. Okay, and 6 plus 1 is 7. So 6 equals 7 is not true. So that means this is not a solution. Okay. So is 2, 6 a solution to y equals 3x plus 1? No, it's not a solution. Okay. What about the second one? Is negative 1, 4 a solution to the equation 2x minus 3x equals negative 14? Now again, is this a linear equation? It doesn't look like our parent function. It doesn't look like the previous one. This should be 3y. Is 2x minus 3y equal to negative 14? Well, there's not variables multiplied together. There's not exponents on either variable, and there's no variable in the denominator. All of our exponents on the variables are 1, so this is a linear equation. It's just in different form. But the same thing applies. We're going to plug in negative 1 for x. We're going to plug in 4 for y. And we're going to see if we get a true statement or a false statement. If it's true, it's a solution. If it's false, it's not a solution. Alright, so 2 times x will be 2 times negative 1. Minus 3 times y, which is 3 times 4. And we're going to compare it and see if it equals, the left side equals negative 14. Okay. Well, 2 times negative 1 is negative 2. Again, we're just evaluating. We're not solving. We're just going through our operations. Negative 3 times 4 is 12. Negative 12 minus 12 equals negative 14. And negative 2 minus 12 is negative 14. And negative 14 equals negative 14. So this one works. So yes, that is a solution. And this last one I set up is a graph. Okay. So we're going to see if either negative 1, 2 or 3, negative 3 is a solution to this graph. So what I would do is I would just plot both of these points. Okay. If it's on the line, it's a solution. If it's not on the line, it's not a solution. So negative 1, 2. It's back 1, left 1, up 2. I'll put an X there. That looks like it's on the line. Okay, it's not perfect because most hand-drawn graphs aren't going to be perfect. But that is on the line, so yes, it is a solution. The second one, 3, negative 3. Okay, so we go right 3, down 3. Put an X there. That one's close to the line, but it's clearly not on it. So no, that's not a solution.